Yeah, so welcome to Thermodynamics. Okay? Now, two things I want to emphasize. When we have a thermodynamic system, okay, especially for a steady flow, meaning that things enter and things exit. Our entry point can be considered as 1, and our exit point can be considered as what? 2. So as things enter, we have got the velocity shall be called C1. As they exit, velocity shall be called C2. The area here shall be called area 1. The area here, area 2. Specific enthalpy there, H1. Here, H2. Okay? Specific volume, V1, V2. So, you need to realize that in engineering science, we were using V for velocity, V. Here, we use C. Why do we use C? Because V is meant for specific volume. Okay? Now, what you have to understand is that thermodynamics, here, thermo is about what? Heat. Okay? So, in a thermodynamic system, what happens is that we are supposed to apply what? Heat. Denoted by what? Q. When we are applying heat to the system, Q shall be positive. Because our intention is to apply heat so that the system can give us what? Work. That's the whole idea of thermodynamics. We apply heat so that the heat can give us what? Work. So, in the engine of a car, what happens there? In the engine of a car, we have got the bomb. We have got the fuel exploding that is producing heat. And when it explodes, it pushes the piston. That is work being done. So, whenever heat is going in the system, shall be positive. Whenever work is coming out of the system, it shall be what? Positive. Negative. Positive.
Positive also.
Yes. Heat comes in is positive. Work comes out is a positive.
Positive.
When the reverse happens, when work goes into the system, it becomes what? Negative.
Negative.
When heat comes out of the system, when heat comes out, it becomes what? Negative. This is when we say find the heat rejected. When heat is rejected, it means it is coming out of the system. And that is negative. Why is it negative? Because our desire is that heat should be used to produce what? work.
Work.
So, Mr. Katebe, that marks the end of thermodynamics. All what we shall be doing is based on these factors. When heat goes in, positive. Work comes out, positive.
Positive.
When work goes in, negative. Heat comes out,
Negative.
negative.
Positive.
Thank you. Can you read question 1?
Okay. Question 1 reads, air enters a gas turbine system with a velocity of 105 meter per second.
So data, air enters. So C1, 105 meters per second. Okay? So we are going to say, wait, at entry. Okay, then we are going to say at the exit.
Exit.
So things that are happening at entry, we record them here. At exit, we record them there. Okay, proceed.
And as a specific volume of
105. Specific volume
0.80 meter cubed per kg.
Meter cubed per kg, correct?
The inlet area of the gas turbine is 0.05 meter per second.
So the inlet area, area 1, 0.05
meter per squared. Meter per squared.
Meter squared.
Yes. At exit, the air has a velocity of 135 meter per second.
So we come here now. C2,
yeah,
135 meter per second.
And as a specific volume of 1.3 meter cubed per kg. In its passage through the turbine system, the specific enthalpy of the air is reduced by 145 kilojoules per kg.
So,
and the air,
now we need to understand. So we are saying specific enthalpy is
145
is reduced by
145 kilojoules of kg.
So this 145, is it H1 or H2?
About H1.
No, they have not said the specific enthalpy at entry. And they have not said the specific enthalpy at the exit.
Exit.
So we don't know what is at entry. We don't know what is at the exit. Are we together? But all we know is the reduction. The reduction. So reduction simply means that H1 is greater than H2. Is that correct?
Yeah.
Reduction, it means that H1 it was bigger at the entry. Is that okay?
Yes, it's okay.
Because I've said it has reduced.
Reduced.
If they had said it has increased, we are going to say H2 is greater than H1.
H1.
Hello, do you understand that concept?
Yes, sir.
Yes, so a reduction, it means H1 was higher. An increase, it means H2 is high. Good. So this statement does not mean H1 or H2. What this statement means is that H1 minus the smaller one, H2, is equal to 145 times 10 to the power 3 joules per kg. Are we together? Proceed?
Yes, sir. Yes, proceed.
Yes, proceed with the question.
All right. And the air also has a heat transfer loss of 27 kilojoules or kg.
So, heat transfer loss. Meaning that Q has been rejected. If it is a loss, it means the heat was lost to the system. Heat was lost from the system to the surrounding. Are we together? So what is the value?
27 kilojoules per kg.
Okay, let's just deal with the kilos. Even here, it will be negative 27. Why negative? Because it is a loss.
Yes.
Heat has been lost to the surrounding. Whenever heat is lost from the system to the surrounding, it's negative. But when heat is given to the system, it's what? Positive. Proceed.
Positive. Determine the mass flow rate of the air through the turbine.
So, Mr. Katebe, Mr. Hendricks, you're welcome. Hello, Mr. Hendricks. Mr. Katebe.
Yes, sir.
Ba Hendricks taveshi padi mute na mic. We proceed. So, listen, gentlemen. The matter with applied thermodynamics, you need to understand the language. You need to learn the language. So when we say enthalpy reduced, just know that H1 minus H2. If enthalpy has increased, it will be H2 minus H1.
H1.
Good. Heat transfer loss, negative. Heat rejected, negative. Heat supplied, positive.
Positive.
So, what is question 1? Roman numeral 1. What do they want us to find?
Determine the mass flow rate of the air through the turbine.
Mass flow rate. What's the formula for mass flow rate? M with a dot. Mass flow rate. M with a dot. Okay?
Okay.
Is equal to C multiplied by area over specific volume. Or is density multiplied by area multiplied by velocity. But remember that density is the same as 1 over specific volume. Okay?
Okay.
So in some books, mass flow rate will be given as density multiplied by area multiplied by velocity. But when you are given a specific volume, just use velocity multiplied by area multiplied by specific volume. So we are going to use the parameters at 1. So C1
105
multiplied by A1
0.05
over V1 0.8 punch.
One zero times 0.05 times 0.5 6.5625
6.5625.
yes
6.5625. What are the units? Mass flow rate is kgs per second. And that is how you are going to pass. Hello?
yes sir
This is how people pass.
yeah this is how I'm going to pass.
Yes. And then you will graduate.
Yes.
And then they'll shout, Daniel Katere! And people will be clapping. We proceed. Next part of the question.
Determine the exit area of the turbine.
Exit area. Okay? So at exit, we know C2. What is C2 at exit?
Sir, I didn't copy the chapter.
No, it is in the question. Was it not 135? Don't worry, you will copy when you're watching the video.
Yeah, 135.
Correct. And the specific heat, the specific volume?
1.5.
1.5 or 1.3?
Is it not 1.5?
No, read the question.
At exit, the area has a velocity of 135 meter per second and has a specific volume of 1.5.
Okay, it's 1.5.
It's 1.5.
So 1.5. And the area, we don't know. That's the one they want us to find. Okay? Good. So, the mass flow rate is constant. M at 1 should be equal to M at 2. Are we together?
Okay.
This is a steady flow energy equation. What does that mean? What enters should be equal to what leaves. Are we together?
We are together, sir.
The amount of mass entering the system should be equal to the mass existing in the system. The system. Okay? So here we have found our answer as the 6.5625. Even here should be 6.5625. Are we together?
Yes, sir.
Good. Therefore, we shall say, we are going to say 6.5625 should be equal to the C1 C2, 135 times area 2 over 1.5. So this is 6.5625 is equal to
multiplied by
90 A2. When you solve for A2, A2 will be equal to 6.5625 divided by what? 90.
9, 6,
Yes. 0.0. Where is the noise coming from?
I think it's coming from Hendrix, because me, I can't even see now. Even you could
Hello?
have said, I can hear you, but I can't see. I don't know what has happened. Mr. Hendrix, we could have joined without a video.
Mr. Katebe.
Okay, I can see also. Now I'm able to
Yes,
see.
now he has joined. He has joined now.
Are you able to see?
Yes, sir. Now it has gone again.
Kashumba,
Mr.
where are
Katebe,
you?
can you see me?
No, I can only see Kashumba. Me, I can only see Kashumba.
You can only see Kashum.
Yeah, now I can see you. Sir.
Even I can see you, sir. Even I can see you now.
Yeah, I'm back now, so I can see you.
Okay. But can you mute Mr. Kashum? Mr. Hendrix, can you mute yourself? There's too much noise.
Okay, sir.
Good. Thank you. Mr. Katebe, are you able to see me?
Yes, sir. Loud and clear.
We proceed. 0.073 meter squared. That is the area at exit.
Area 2.
Yes, at exit. We proceed.
Okay.
Part 3.
Then part C.
Yes.
The part C leads determine the power developed by the turbine system in kilowatts.
So our third and last part, power developed in kilowatts.
Right.
What is the power developed? State flow energy equation. Whenever the question starts with air enters, just know that that is the state flow energy equation. Okay?
Okay.
And the
Right,
state
sir.
flow energy equation states that H1, which is the enthalpy at entry, plus energy due to velocity C1 squared over 2. But because we are dealing with a kilo, this will be 2,000. You multiply by 1,000. Because you want the answer to be what? Kilo.
Kilo.
So H1 shall be in kilojoules. And when
So
we
if
divide
it was
by 1,000, we are making it to be kilo. Okay?
so if we if they said it in joules, we could have multiplied by 1,000. It could just remain
Exactly.
2.
Because
Alright,
what
sir.
is happening here, this is kinetic energy. What is kinetic energy? Half m v squared. But because the mass is specific means 1. So this becomes v squared over 2. Okay?
Yes,
Because
sir.
the mass is 1 kg. But we don't use v because v is used for specific volume. So you see, c squared over 2.
C.
That's where it comes from. So you have got the specific energy, and then you have got also the kinetic energy. The enthalpy, the kinetic energy. Are we together?
Yes, sir.
Plus potential energy, which is Z. But since in this question, so here it will be Z1. Okay? But since in this question, the height was not mentioned, so this one is ignored. Are we together? So we only have
Yes, sir.
specific enthalpy and the kinetic energy. Okay? This must be equal to specific enthalpy at 2 plus kinetic energy at 2. Are we together?
Yes, sir.
Now, this is just energy. But for thermodynamics, what do we do in thermodynamics? We add heat.
It
Okay?
is to
Why
get
are we
weight.
adding
Yeah.
heat? We add heat to the system. Are we together?
Yes.
So heat will always be on the left-hand side. Okay? Why are we adding heat? So that it can produce what? Work.
Weight.
So we add heat to produce work.
Weight.
That's instead from energy equation. Specific enthalpy plus kinetic energy plus potential energy plus heat should be equal to specific enthalpy plus kinetic energy plus potential energy plus work done. So H1 to H2, okay? C1 to C2. Are we together?
Yes.
We add heat to give us what? Work.
Weight.
That's thermodynamics. DDK, umwana umwe. Wali watu wakale mwasanga natupwa nomba.
Tampwira sa fomu amba vyokula nomba pana mbo kuwera munshira nali mumpanga sa.
So what was H1? H1 was not given. Okay?
Yeah.
So H1 plus C1. C1 was what? 105 squared
105.
over 2000
Right.
plus Q. Q was rejected, so it's negative. Negative 27 equal to H2 plus C2 155 squared over 2000 plus work. And this is what we want. When we find the work, then we can find the power. Okay?
Yes, sir.
Can we bring H2 to the other side of the equation?
Yes.
So H1 minus H2 plus what is 105 squared over 2000?
101.
5.5125.
Yes, 5.5.
What is 155 squared divided by 2000?
35.
9.1125.
Okay. 9.1125.
Good. And what was H1 minus H2? We found H1 minus H2 was what? 145. Yes or no?
145. Yes,
Yes.
145.
So that was the reason why it was very important for you to understand that when they say specific enthalpy has reduced, it is H1 minus H2. So 145 plus 5.5125 minus 27 minus 9.1125 is equal to work. Like ndupange kwa ma technologists unomwaka. Notifilia ba milepo.
Pangeni sir.
Abasambira tufuleko pa Z.
Nisho
114.4 is equal to weight. And this is in kilojoules. Okay? Once you find weight, it means you have found what? Power. How? This is the how. Don't worry, I'll send you the video. Power is equal to mass flow rate multiplied by what? Weight. So the mass flow rate we found in part A, that was the reason for us finding mass flow rate, which was 6.5625 multiplied by weight 114.4. Punch tizo.
750.
And this is the answer, even in the marking key for table.
750.75.
And this is how you will pass. When is the exam?
August. It is in August. The exam will be in August.
August 2022 or 2023?
2022, sir.
And the people still want to be begged to learn. Okay. Me, I'll go with those who are ready to go with me.
Yes, sir.
So, gentlemen, this is how it goes. Are you happy? Happy you?
Yes, I'm very much happy, sir. Now I'm beginning to feel I'm a student now.
Can I give you another question, which you must try, and then we can solve it at the 20 hours?
Yes, sir, you can.
So I want you to go through this video and copy this question. And after you go through this video, you copy the question, then you are going to try the one which I'm going to send to you just now. And then at 20 hours, we'll go through it together. Then tomorrow,
yes, sir.
Tomorrow we look at fluid mechanics. Vambero vaisa, wasanga valetea.
Vana nyao vaisa sir.
Shiveshi vatwa eziye okunda kuwaya wayafe vakumanza.
Amachitwavo. Abo nchito naba bakomera ku nchitwavo. I'm a business.
Let me send you the video. You go through the video, you copy it nicely in your book, and then you try the one I'll send you, then we solve it together at 20 hours. May God richly bless you. See you in 20 hours. Thank you.
Send me the video as well.
No, the video I sent it to those who have paid.
Okay, Mr. Koroto.
Yeah.
When you pay, it will show.